Okay, before we move on to any more differentiation rules, let's take a look at another example. So in this case, we're going to use the basic differentiation rules, just the power rule, constant multiple rule, the sum or difference rules, those things. But we're going to get clever, and we're going to use them to differentiate something which is not just a polynomial. Okay, so here's a function, a rational function, 2 plus x divided by 2 times x. You may be thinking, well, that's a quotient. That's something divided by something else. Don't we need some sort of special rule for quotients? No. We're coming to products and quotients soon, all right? But we don't actually need that just yet because we can leverage algebra to our advantage. All right, so first, we're going to do some algebra on G. Okay, let's take 2 plus x divided by 2x. And let's distribute the division. Remember that division is just multiplication in disguise, so it distributes over addition, just like multiplication does. So I'll distribute that division by 2x, like this. Then we can simplify each one. So this is going to simplify to 1 over x plus 1 over 2. Or in other words, x to the negative 1 plus a half. I didn't bother writing 2 to the negative 1 because it's just a constant anyway. But x, I did write the power negative 1 because I want to be able to apply the power rule. Having written it this way, having taken this and rewritten it like this, now it's in a form which is much easier to apply differentiation to. So now differentiate. G prime is going to be the derivative of x to the negative 1 plus the derivative of 1/2. Now I'm applying the sum rule already very quickly. Just rewriting this here, right? Without even writing the derivative over the entire thing, I'm just jumping in. And I'm using the Euler operator notation here just because I like it. It's convenient. You don't necessarily have to write it exactly like I do. There are other ways to do this. Anyway, the derivative, first we want the derivative of this x to the negative 1. That's just a power rule. So we can apply that's just a power function is what I meant to say. So we can apply the power rule. So the negative 1 comes down as a multiple. Then we reduce that power to negative 2. We've already done that example in a previous video. And what about this? We could say this is 1/2 times the derivative of 1, and as we've learned before, the derivative of 1 is 0. But you may have figured out by now, in fact, anytime you're taking the derivative of a constant, no matter what constant it is, it's always 0. All constant functions are horizontal lines, and therefore they all have a constant slope of 0. So anytime you have a constant, its derivative is 0. And there we go. The derivative of this is just negative 1 over x squared again. Same as the derivative of x to the negative 1, but the function was actually this. So there we go. I just wanted to show you how we can use algebra to our advantage to simplify things, or at least manipulate them in ways that make them more manageable, more approachable with just the basic rules we've already learned.